Hello everyone, thanks for tuning in. The McGill Pain Questionnaire, or MPQ, is a well-established tool used by medics in the diagnosis of pain. It's designed to capture both quality and intensity of a patient's pain. This presentation examines its content in light of corpus data. Critically, the MPQ is a language-based instrument, a list of single-word descriptors, adjectives, organised into 20 groups. Patients are asked to select one descriptor per group. It's assumed that each group of descriptors labels the same quality of pain but varying intensity according to the within-group order. This is the original MPQ created by Melzack. Let's ignore the diagram and the comment box. Each little box sections off a group of between 2 and 6 descriptors. So for instance, here's group 7, the hot pain group. If the patient's pain isn't hot, they skip the group, otherwise they choose one of the 4 words, hot for the lowest level of pain and searing for the highest. Here's group 4, the sharp pain group, with 3 levels of intensity. Confounding factors are anything that affects the results other than what you're researching. And it's known, for instance, that the manner in which the MPQ is presented can influence the results. What about language confounders? May in 2016 suggests that patients' choices may be influenced by language, knowledge or usage. So this is a possibility that pain researchers do know about, but it's not been looked at on an empirical linguistic basis. We're considering how cognitively accessible the descriptors are to the patient. Do patients pick a descriptor not based on intensity, but based on how swiftly they can access that word in the mental lexicon? A word can be accessed more easily if it is entrenched, informally more familiar or higher frequency, or it can be accessed more easily if it is pre-activated, that is switched on by priming, i.e. activation of a related item. And we often consider priming along the syntagmatic axis of language, habitual co-occurrence, i.e. collocation. Let's spell this out. Let's assume that pain has collocational links with both hot and searing for English speakers, but collocates with hot more strongly. So our speaker is given a choice between hot and searing while talking to a doctor about pain. So pain is activated. Activation spreads along the collocation links. The stronger the collocation, the easier the activation spreads. So hot has strong pre-activation, but searing only weak. The pre-activations influence ease of retrieval of hot and searing. Hot is easier to access because it's already lit up very brightly, and this influences our speaker towards picking hot. But how important is this factor? If the influence is negligible, it's not a problem for the MPQ, but if it's strong, it could be. To find out, we analysed MPQ and corpus data. The MPQ data is 800 responses from patients at a dental hospital experiencing chronic and unexplained pain in the mouth or face. To control for manner of presentation, the same doctor administered all 800 with the same technique, reading groups out to the patient and asking for their choice. We use the Oxford English corpus of 2.1 billion words rather than, say, BNC 1994 because some of the descriptors are quite rare. For each descriptor, we measured its frequency overall in the OEC and its frequency within 5 tokens before or after an instance of the word pain. Our question, does the strength of collocation with pain predict what descriptor the patients select? So we need to measure collocation strength and to measure the probability of the patient choosing a particular descriptor. The higher the correlation between these two variables, the more variation in patient responses is explained by collocation strength, and the less there is for pain intensity to explain. First, the response data. From this, we calculate P chosen, the probability of a patient picking the descriptor, given that the patient picked something in that group. We ignore patients who didn't pick anything for a given type of pain. Here are the numbers for group 1, on and off pain. 446 out of 800 patients chose nothing. So, for instance, flickering. 18 patients chose flickering out of the 354 who chose anything in group 1. Divide it and we get P chosen 0.051. From the corpus data, we calculated the probability of the descriptor given pain. That is, the probability that the descriptor is a collocate given that the node is pain. This is not a standard collocation measure. It is a bespoke measure. It's devised specifically for this analysis. Also, it's a pure effect size measure. It measures collocation strength, ignoring frequency, exclusiveness, and dispersion. It's asymmetric. Its association strength in one direction only, from pain to the descriptor. And if you're not familiar with symmetric versus asymmetric, I recommend Grease's 2013 paper. So P descriptor given pain equals frequency of the descriptor co-occurring with pain divided by the total frequency of any descriptor co-occurring with pain, and that second value is a constant 8,691. And here's that calculation done for group 1. Next, we look at the correlation of these statistics, looking at both Pearson correlation, which is based on similarities in the probabilities, and Spearman rank correlation, based on the rank within group of each descriptor's probability. And both of these give us a correlation coefficient, symbolized as R. Related to R is R squared, and R squared tells us the proportion of one variable that is explained by the other. R is interpreted via generally agreed rules of thumb. R ranges from 0 to plus or minus 1. Anything above 0.3 indicates a correlation, anything less is just not worth mentioning. Above 0.3 there's low, moderate, high, and finally R above 0.9 is a very high correlation. And if you look at the corresponding R squared percentage of data explained, then you can probably see why these are the guidelines. So, here are the headline results from all the numbers. The Pearson correlation for all 78 descriptors is 0.307, Spearman 0.603, so low, moderate, respectively. Why is rank correlation better than correlation of the actual probabilities? Well, there are drastic differences in the values of the actual probabilities across groups. Converting probabilities to ranks within group does a good job of smoothing out these differences, and we get a better correlation. It's easy to see from the scatter plot why we get a low or moderate correlation. There's a big cluster of points near to 0 on the x-axis. Most descriptors collocate infrequently, and most of those are fairly rarely chosen. But what about correlation within each group? Let's repeat the correlation analysis but once per group. This means we'll only have 6 data points maximum, but the data points are going to be more relevant to one another. Incidentally, from now on, I'm ignoring the 3 groups with only 2 descriptors each. This table showed the number of descriptors per group, then the correlation, and then the Spearman rank correlation. The numbers in bold are 0.5 or higher, i.e. moderate or high correlation. And we see multiple really high coefficients. Some low ones too, but still, it's very notable. Group size doesn't seem to matter. There are very high coefficients in both big and small groups. On the scatter graphs, many groups have a cluster of points near the origin plus one outlier. That is, one descriptor is a strong collocate, the rest aren't, and the collocate is drastically more likely to be picked. That explains the very high R for group 1, the outlier throbbing. The linear relationships do not always rest on a single outlier though. In group 7, there's a very clear spread. This is the hot group. A few groups, the minority, have low correlations, such as group 10. My educated guess is that the quality of pain is not actually all that similar between tender and splitting, and that factor is more important than collocation strength here. For most NP descriptor groups then, collocation with pain is shown to explain patients' choices nearly completely. Sometimes that's due to one powerful outlier, and sometimes it's all across the group. That means there's not much left to explain for these types of pain. For group 1, for instance, R is 0.96. That explains 92% of the variation in descriptor choice. Can we say the entire effect is due to the linguistic confounder? No, that's going too far because of limitations in the analysis, especially the small number of data points per group. But don't forget, we got a pretty reasonable rank correlation of 0.603 for all 78 descriptors together, so the small group size is not so big a problem. We aren't saying that the MPQ is utterly broken, rather that parts of it look kind of shaky. Our findings indicate that at the very least, instruments based on word selection shouldn't be deployed without due attention to collocation and discourse frequency. Using corpus linguistic evidence can help medical researchers to avoid linguistic confounders when developing language-based instruments and to identify them in existing instruments. Finally, some medical studies using the MPQ may need to be reassessed with a non-confounded instrument depending on which descriptor groups were in focus. That's all. Thank you for your attention.